recording your audio from Teams also. Okay then, yeah.
Yes, you are live.
Should we start? Okay. Swati, please go ahead.
A very good evening to one and all present here. I, Swati Patnaik, research scholar of Department of Industrial and Systems Engineering, welcome you all to pre-RSA workshop. The Internet of Things or IoT refers to billions of physical devices around the world that are now connected to Internet, all collecting and sharing data. Any physical object can be transformed into an IoT device if it can be connected to Internet to be controlled or to communicate information. For example, a light bulb. If it is connected to a smartphone for switching on, then we can say it's an IoT device. An IoT device could be as simple as a child's toy, or it can be as serious as a driverless car. Some larger objects may themselves be filled with many small IoT components, like the jet engine. That's now filled with thousands of sensors, collecting and transmitting data back to make sure it's operating efficiently. So today we are arranging a workshop on Internet of Things or IoT through hybrid mode. It will be presented by Saurabh Bagchi, Satyajit Swine, and Shubhati Bardhan, research scholars of our department, working under Professor Mamta Jenamani, Professor and Research Scholar Coordinator of the Department of Industrial and Systems Engineering, IIT Kharagpur.
Hello, am I audible? Okay, thank you Swati for this introduction. So I am Saurabh Bagchi. I am currently doing my PhD under Professor Mamta Jenamani of Industrial and Systems Engineering, IIT Kharagpur. So today I am going to present this workshop on Internet of Things, an overview. So in my team there is Satyajit Swine and Shubhati Bardhan. They are also doing masters in this department, and then we will start presenting. Okay, in this presentation actually there are the contents are like introduction. I will be introducing some of the things which are the components of IoT devices, and second one demonstration will be on IoT device like Raspberry Pi, and another will be another IoT device will be demonstrated by Shubhati Bardhan, and then we will ask we will be taking some questions. Okay. So this is actually a typical IoT architecture of a supply chain, more specifically a cold chain. So here what we do is generally we transport some perishable items or some consumable items in a cold chain. Some medications also are there. So road transportation are included, and sea transportation are also included in this section. There are actually 3 layers. So in the first layer, which is the physical layer, where we physically put several sensor nodes in 2 different locations of this shipping container, and then comes the communication layer, where through these IoT devices, through internet actually we send the data to remote database. And third, for data visualization, for better understanding, we use some web applications and Android applications for better visualization. Okay, so some of the problems we face in this individual layers. So in the first layer, first physical layer, also we can face some of the interruptions like malfunctioning of sensor devices and all. So some outliers can be generated, and missing data can also be generated here. So we have some algorithms which encounter this kind of problems. Okay, in the communication layer, some synchronization issues generally occur. So we also have to think of some of the algorithms which can tackle this kind of problems. And in the third layer, which is purely a visualization layer, we generally fetch data from database and we show it in Android or web applications. Okay. So what is actually edge computing? In this slide, I will be explaining what is the edge computing. So these are some of the applications like transport and logistics, smart cities, smart buildings. So here we always use some sensors. So these sensors are connected to a device which is capable of aggregating all the sensor data and sending and it sends the data to database. It has a small database inside it embedded in these devices, and it has a small processing power also. These are computationally not very efficient devices, but some processing powers these devices have. And most importantly, these devices work as a gateway to send the data through internet to a remote database. So there are some properties of these edge computing devices. These are like fast response time. So as these devices are present physically close to the physically close to those applications we are focusing on, so the response time should be fast. Second is reliability. We have these devices must be reliable enough to it's true not to maloperate while sensitive work is being done. Second is hardware security is another issue. Someone can tamper the data. Okay, and these devices must be cost effective also. And interoperability is also another thing where multiple edge devices are connected, and we have to make sure that all the devices are working simultaneously. So these devices actually have some data logger. As I said earlier, that data logger is also inbuilt in these devices, but the volume of data we can save is very less. And sensors are interfaced with these devices, and it has a very good connectivity. It has to have a very good connectivity of internet. Some internet connectivity module should be there, like Wi-Fi. There is LoRa, that is low range, and Zigbee protocol can be accessed by these edge devices. Okay. Moving to the third slide, that is actually on cloud computing. So cloud computing is actually manipulating, configuring, and accessing applications through online mode. So that is actually cloud computing. So depending on the deployment models and service, we can classify these cloud computing into 4 different parts of based on this deployment of the models, and we can classify it into 3 different parts depending on this service of the cloud models. So first we will be talking about the deployment model. So first one is public cloud. So as we know, some of the applications which are online can be accessed by a generic public. So as an example, we use our Gmail account. So this is a public account, so public cloud service. And second is a private cloud, where some of the organizations, a particular organization provides a cloud service to their employees, or this particular organization is using this cloud application. So this is the private cloud models. And second is community cloud. So multiple private cloud organizations, if they are bonding together and building a community and they are using a cloud service, then it is community cloud. And hybrid, as its name suggests, like they are using private plus public cloud services. Okay, proceeding to the service-based models. So the service-based models are, first is infrastructure as a service. So infrastructure means we are delivering some technology directly. We are delivering some technologies to the as a service. So like this entity communications or something, they are some technology providers. Okay, and platform as a service is PaaS. So they provide some platforms where we can develop or deploy some models, some code also we can deploy here, some applications we can develop there, and also we can deploy to this platform. So these are like Amazon Web Services is also, we can say this is a platform as a service cloud. Okay, and last but not least, actually this is the software as a service. So as you know, if we can have some softwares which are used in online mode, like Facebook, so this is software as a service. So I will not be going deep into this cloud computing stuff. So I will be directly going to move on to my next slide, which is on edge and cloud relation. So what is the relation between edge and cloud? So here in the right side, in the rightmost side, we can see a refrigerated container. Inside that, some perishable items are there for the sake of example. So here in different locations, we have put some of the sensors, and those sensors are sensing data and they are sending the data to this particular edge device. So this edge device can also process some of the data, but there is not enough computational capability to process all the data. So the basic difference data volume comes. Like we cannot handle a big volume of data in the edge devices. Okay, then these edge devices send the data to cloud. Okay, where we have some database, some servers are also there, cloud servers. There we can process. So here we can say the computational capability is very high. So we can either offline process the data or we can process the data in online mode. So time sensitivity is one of the differentiating factor which differentiates the edge and cloud computing. So we can say, like in the edge computing devices, there must be some algorithms which are fast enough to handle real-time data. But in the cloud computing, we can implement those faster algorithms. But the thing is, cloud computing can handle it can run in offline mode, so we can handle a large amount of data in cloud computing using some offline methods. Okay. For visualizations, for better understanding, we generally fetch data from these cloud servers and show it in any Android or web-based application, or Android or web-based applications. And this is the cloud and edge computation relation. What is the relativity between them, and the differences also I have also explained. Okay. In this workshop, actually, I want to show some two IoT devices. Namely, one is Raspberry Pi. This is a typical IoT device, which is Raspberry Pi. So these are some applications. So we can connect to these applications using these relays. Relays are some switches. These switches are controlled by this device. This is a computer-like device which can control these switches, and through these switches we can control these applications. Okay. The IoT device can send the data to cloud, and we can access this data, or we can manipulate those data and control also from some web-based or online applications. If we are present in if we are present physically near to these applications, then we can directly access this Raspberry Pi, this IoT device, through online methods, web-based applications or any Android application, and we can control these applications. We can actuate some of the actuators if it is present through local network also. Okay. Now I would like to proceed further. I would like to show some basic programming through which we can use we can actuate some IoT devices. So I would like to directly go to that programming part. Okay. Okay. So now what we are going to do, suppose this I am connected to this network using this laptop. So suppose this laptop is an IoT device. Before going directly into this IoT device, I would like to theoretically present that what we are actually going to do. So this is suppose an IoT device, this laptop. So from here I will be hosting a server. So we are using Flask server for this. So these are some of the libraries we have to import So first we need to import this numpy and this Flask library, and we are trying to control this from a remote application like web application. So for that we have to render data. So render template, this is one of the libraries of Python. So this we can also import, and request is also another library. Okay. So this particular piece of code is to know what is the IP address of my device. My device means I am talking about this IoT device, which is a laptop as of now. Okay. Then we need to go to a particular URL. We need to hit an URL where we can control. So for that, the home URL is set up like this. One flag is hosted, that is a equal to 0. So I have set it in this way, like if a is equal to 0, then it will show the status is off. Otherwise, if a is equal to on, then it will show the status is on. And I am using port number 5000. So 5000. Okay. So after that, I will show this HTML code. Before going to this HTML page, I will show the code. So this generally stays same for all the HTML pages. So here LED controller I have written. So in the HTML page, LED controller will be this will be written in this font and size, and then it will show the current status. What is the current status? This will show, and here are two. Okay, I think it is right now. Okay. So these are the two conditions. Okay, as I said earlier, that if the A's value is 1, then it will show the status is on. If it is not 1, that means 0. Only two values are there, binary values I have taken. So then it is off. Okay, and two buttons I have implemented here. So if it is in the off mode, I have kept at the home URL, the status is off, and if we change this status to on, if we click on this on button, then it will be on. Okay, now let me directly go to that web page and show you. Okay, before that we need to run this server. So for that I am running it from terminal itself. So you need to write Python, and the file name is, now the server is running. Okay, so now we have to know actually what is the IP address of this device. So there we have to hit. So then we have to open another CMD, and we have to another command prompt, and we have to write IP config. So it will show your IP address. I mean the whichever IoT device you are using, that IP address must be there with you. So this is the IP address. I'm just copying it. Okay, and as I have shown earlier, that the port number is 5000. So we can directly go to any browser and put that IP address colon that port. So it will show you this interface. This is a basic interface. I have already shown you the codes regarding this HTML page. Okay, so the status is now off. That means A is equal to 0. It is directly connected to that IoT device. We can, if possible, we can open this URL from another Android phone or some another web browser. That is also fine. So okay, if we click on this off, so this remains off, and if we click on, then the status changes to on, because now the A value is 1. Okay, so the same thing now I will be showing you using the actual device. Okay, so let me just set my camera to that device. Okay, so I am turning off this server. Okay, So this is the Raspberry Pi module which is here with me. I think you guys can see. So here I am trying to connect one LED and I am trying to control this LED using one web interface. Okay, so the same interface I will be showing. So before that, I need to host a server by accessing this Raspberry Pi. Inside this Raspberry Pi, I need to host a server. So for that, what I need to do is I need to how to set up this Raspberry Pi. I think that is another thing. So this is, I think, beyond the scope of this workshop because it will take much time to talk about. So I think I will be directly jumping into that Raspberry Pi connection, and don't worry. I think these supports are available. Online supports are available for setting up Raspberry Pi. Okay. So now I know what is the now I have to know what is the IP address of this Raspberry Pi. Both my laptop and this Raspberry Pi is connected through same network. So I have to scan this device as I know already. So I can directly go to this VNC viewer, which this VNC is actually another application which allows us to remotely access this Raspberry Pi. So this is actually the IP, the 10.29.2.80. So yeah, I'm inside this Raspberry Pi now. Okay, as you can see. Now, before starting, I need to connect this Raspberry Pi, connect this jumper wires to Raspberry Pi. So for that, I have another slide. Yeah. So this is in the right side. This is a pinout diagram of Raspberry Pi. So counting starts from here: 1, 2, 3, 4. These are the numbers of board. These are the physical numbers, pin numbers, and these are the BCM. Actually, we specify those GPIO pins, GPIO numbers, and which are slightly different from the numbers which is available on the board. So I am connecting this LED. One leg is connected to ground and another leg is connected to the any one of the GPIO pins. Okay, so as we know from this pinout diagram, one leg is connected to the GPIO pin and another one I can connect to a to ground. Okay. Now let me go to Raspberry Pi again. Here there are some environment, some development environment where we can run our Python scripts. So this is the same script that I have shown earlier, which is a Flask server. Just the difference is instead of using that flag that which was a equal to 0 and a equal to 1, we are here changing it to the GPIO input. Like we are just sending an input to that LED. Okay. So I'm just running it now. Just a minute. Maybe this port is busy, so 5003 should run. Yeah. Just a minute. It is not showing, but it 5003 is I think all right. Yeah. Okay. So now it is already hosted, and before that we need to set up those GPIO. So in the set mode, see, I have used this board numbers. So 11 is the GPIO of 17. So if I use 11, I need to specify it is board pin number. So that I have already specified here. So this we need to specify, and the server is running. So let us just access it from another device, which is my laptop now. Okay. So this was the IP address, and port number was 5003. Should run. Yeah, the current status is off, so you can see the LED is off. Now if we switch this on, the LED is on. Can you see? I think you can see. I'm still again switching it off and again switching it on. So if anybody present here physically who has a laptop or phone, they can also open one browser and write this IP address, that is 10.29. Anybody is using 10.29.2.80, then colon, and then 5003. So you can see this interface. The same interface, I think it will be showing in your browser. Okay, so your laptop is in this network, so you can see. Can you see this? Okay. So any of the Wi-Fi network you can connect, and then the IP address is, I'm saying it again, 10.29.2.80 colon 5003. Is it connecting? Can you see this interface, web interface, which I am showing right here? Okay, then you can switch it on and see the light will, yeah, very nice. So this works as an IoT device. So up to this much I will be showing for today. So from now on, I think Shotvit will take over, and he will be showing you some another sensors and how to fetch data and how to show it in real time, that he will explain. Thank you very much. Just a minute.
Shall I start? Okay, thank you, Saurabh, for giving a brief overview on the IoT and its structure and a small demo. Now, what I will be showing is the real-time data on the web and the server. Basically, what we are using is we are using a system where we are hosting some web pages as a server. We are not using any kind of AWS or Google Cloud platform for hosting our web pages. So what I will show you is the Raspberry Pi. It collects some data, for example, temperature data or humidity data, and it forms a packet and it sends to the database. And how the database is communicating and what all are the frameworks and what is the database, what is the server features, that I will be showing here. Currently, as Saurabh said, there are mainly 4 parts. First is your Raspberry Pi, that is IoT device. Second is the API layer, where you can communicate, where you can send and communicate with the web server. And third is the web server, which is the most important machine which renders all your requests and web pages. And fourth is nothing but the visualization part, where you have to go through all the web pages stuff. For example, that is HTML, CSS, JavaScript, and to some extent you need a web framework where you can host everything as a whole. So what I will be sharing is my server. Currently it is hosted. So I am currently logging into my system, which is there in the department itself, and I have configured it completely as a server so that it can render everything, every IoT services that we want. So this is the machine which is a Linux based machine, and I am currently using this as my web server. So I will be explaining you for how it works and what all are the features I am currently publishing. So first of all, I will show you the IoT device. Zoom
control installer.
Remote login.
Just tell that
we can basically, if you cannot see, actually we cannot currently zoom in because I am currently remotely connected. So I will be explaining all the codes, no issues. Firstly, I will be showing you the connection of Raspberry Pi with the IoT device, with the sensors. And the sensors are basically a DHT22 sensor, which is capable of capturing temperature and humidity in the ambient. And I will be collecting those data in the Raspberry Pi, and I will be sending those to the web server. And basically, what you see in the web, YouTube is the local host. We will not be using any local host or nothing. We will be using a domain name which is being provided by IIT for our project, and I will be using that domain name to redirect all my requests to that web page. So I will be So this is the connection of the DHT22 sensor to the Raspberry Pi, and I will request Saurabh to please connect it so that we can. So the first wire is connected to 3.3 volt, that is nothing but the power supply, and the second pin is collecting those temperature and humidity sensor through a GPIO pin 7. And I will be accessing this pin to know the to get the access of the temperature and humidity of the ambience where it is there. So hopefully you can see the things are connected. Now, as you know, Saurabh has already told you about the IP scanner and the VNC viewer, which is nothing but software to remotely connect to the Raspberry Pi or the IoT devices. So I will be showing now the Raspberry Pi is completely compatible with Python, and it is a very good language to start your basic coding and web frameworks. So this is Thorny IDE, which is integrated with the Raspberry Pi OS, and I will be showing this is the temp file. So this is the basic connection where what. So PIO is the library which configures the Raspberry Pi to collect the sensors data from the from the devices, and the DHT22 is the library which converts all these which collects the data from the pins which I have specified here, that is setup dot, and I am connected to GPIO pin 7. So I am completely configuring all those and telling this program that this is the pin number, this is the board ID, this is the configuration, this is the library, just use it. And there are some small requests which I am using to send these packets to the web server. Now what I have done is I will be currently commenting this. This is the part where the web server connection is there, but currently I will be show that how the temperature and humidity data are collected. So I will be running this code. Just I need to close the ID, then I will start. Yes. There are lots of stuffs in here. So now I will run this. So you can see first there are first few values will be garbages, and after that you can see that the values are collected. Okay, 62, 52, 25, and I have kept a 2 millisecond gap, and every 2 millisecond will collect the data and will send to the database. Currently I am commented this database connection to show that the current temperature and humidity values are collected. Now what I will do, I will directly go to this to my server, and I will show you that how the connections and web frameworks are set up to collect all these data. Now this is my web server. Is a complete Linux based server, Linux based OS, and this machine is installed in our department, and I'm using this server with a domain name www.qts.iitkgp.in. This domain name was provided us by CIC-IIT-KGP for our project, and we also got a static IP, and I have configured whole my system with this domain name that every request come to this www.qts.iitkgp will be redirected to my system. Now what I will do, as I am also using Flask framework, because Flask is a very basic and So Flask is a very basic Python web framework. With few lines of code, you can host your own server. And I have used those because it is capable of hosting some APIs also. Now, API is basically a program which can communicate with your server because any device cannot send those data to the server. Some specific IoT device is authenticated to send it to the server. So that's what API does. API does is it's collect the data from the IoT device and send it to the server. So API is basically a medium to communicate between these two devices, two machines. Now I will show you this. I'll show you how this is my app where I am I am currently using Mysql database, that is completely an easy to learn database, and this is a table structure and relational database management system where you can learn easily. So I have kept Mysql database as my data logger or database. Now these are basic libraries as Flask. You can install Flask using pip, and Flask Marshmallow is nothing but a package to host your APIs, and it helps you to host your APIs from the Flask itself. So Flask is very powerful framework because it has many capabilities of providing you the APIs, the database connections, the ORMs, the URLs, the endpoint you write is very easy. Now, secondly, this MySQL Alchemy is nothing but a package to connect your system, your app to the MySQL database, and date, time, random time, and import JSON. Now, what I will do is I will collect the temperature and humidity. Currently, I am only taking one value, that is humidity, and I will create a packet, and I will send the packet to the database using an endpoint. So this is the class model. Model is nothing but the database schema, how to store your data. So I have kept ID. ID is nothing but 1, 2, 3, 4. It is a primary key where it automatically gets updated when a new data is fetched or sent. And time is the time versus humidity, at what time the humidity is there. So this is the basic model to have as a schema in the MySQL database. And this schema is nothing but for the APIs, that what every data cannot be sent to as an response to the client. So some data has to be filtered, and I have kept that as an API. So API is nothing but I have trimmed those tables, and I have selected few of these column, and I have created an API. Now I have created 3 endpoints. That is nothing but last. Last is nothing but it will give you a response of what is the last data that is in the database. And this is nothing but the app root. Add endpoint is nothing but it will add data to the database from the IoT device. And this is the home URL where if you are going to www.iitkgp.qts.iitkgp.ac.in, it will render you the home HTML, that is workshop.html. And this data is nothing but a background asynchronous call to from the web page to the database for the live streaming. So this is basically the live streaming part, which I have written. Now, if you want to configure, I am currently using an Nginx server, which has a very good load balancing capability, and you can also go for Apache, no issues. But the problem with Apache is that the configuration is a bit difficult in Apache on with comparison to Nginx. So you can learn with Nginx also. So I have created this whole database. If you want to configure your whole database with the Flask app, I'll recommend this code with Harry URL and Harry, this how to deploy Flask app on Ubuntu using Nginx. You have to just follow this one, and your machine will be a web server. This is the part. And now what I will do, I will show you. I'll open this QTS. So this is the plot, and I will also open the VNC. So I will uncomment this one. So what I am doing is I am creating a count that after five data points, you just send the data to the database. The reason for doing this is that preliminary data are very much the random data, and it is of no use. So that's why I'm creating the data after 5 data points. So this is the packet I am creating, a payload where the time will be there and the humidity value will be there, and I am requesting those to post that data in this URL. This add I have shown you, and I am adding this payload. So what it will do, it will create a packet. It will create a packet in the IoT device itself, and will send those packets to the database for visualization. And you can also do some machine learning models, whatever you want, because the Raspberry Pi is capable of handling these deep learning models also. Now what I will do, I will just run this code. Stop here, sir. See, a response is created, and you can visualize that there is a live data in the this URL. Anybody can hit this URL and can see that this live data has been plotted here. So continuously the data can be sent to the database through an API, and it is currently sending all those data. And you can also change the humidity by throwing some water into it. Okay. Go and take it. So the data are being sent to the database, and we are currently fetching those database to data through a web page. And we can also request if you want to get the last data as last. So it will return a JSON response. This is the way you can always go for the IoT architecture shown by Saurabh, as Raspberry Pi as the IoT device, and the server as the any machine you can use as a server, provided that you have a domain and a static IP. Mm. So I will be so I will be concluding here. Next, I will request Subhadeep to show his part, and we will be showing some ESP32 modules, which is again an IoT device but of different kind. Thank you very much.
Stop sharing. Stop sharing. Dismiss कीजिए. recording.
Hello. Yeah. So go to your course. Good evening, all of you. Hello. So my part is on about miniaturized IoT devices. So basically, I won't be going into details about this cloud computing stuff because it has been already clearly explained by Saurabh and Satyajit. So my part is on basically on capturing multiple data streams and use an Android application to visualize those data streams on real time and to pre-process and to do some basic pre-processing and do some kind of basic decision making stuffs using that IoT devices. So yeah, so the IoT devices which I will be focusing on basically consist of microcontrollers. So these microcontrollers are widely used on numerous industrial monitoring processes and also in automation processes. Like it can be used for fire alarms, or it can be used in autonomous vehicles, or or it can be used with a container like sort of as previously showed. So directly coming to this stuff, I will be showing first I will be showing a demonstration on how to capture like multiple variates and plot those variates in real time using a third-party Android application. It is known as Blink, right? So first I will start by importing the libraries. So first you can see that the library belongs the library, this Adafruit SCD30 belongs to a sensor library. This one is a CO2 library, CO2 sensor library. This has already been previously discussed, so I won't be going into detail. Next, this Wi-Fi and Wi-Fi clients are used by the microcontroller to get an IoT connectivity using Wi-Fi network. Yeah, so just give me a minute. So as you can see that basically
Press control, scroll up. So, yeah. So zoom it in a bit more. I think it is visible now.
okay. So I guess it's visible now. So this Wi-Fi and Wi-Fi client is been used by the microcontroller to get an access with the internet. So the internet is obviously Wi-Fi here. Secondly, this Blink Simple ESP32 has been used to get an connectivity for my microcontroller for the Blink application, which I told you just moments ago. and this timer is used to periodically send my sensor data to this Blink Android app. Next, you can see here these three credentials. The first one is the authorization key. This will be provided by the third-party software services which you are using. So this has been used by this key has been used by me for this device. Second is this SSID and password. This SSID and password corresponds to the network, to the Wi-Fi access point which you are getting connected to. Okay. So next, I will directly come to this section of this code where we want to where we have written the connectivity code for my Wi-Fi connection. Right. So whenever there is a connection, this statement, this Wi-Fi connected, will be printed, and if the status is not connected, then you will simply see a dot. Okay. So after getting my Wi-Fi connected, I will use an initializer to initialize my connectivity with this Blink software. So again, using these three credentials which I've already told before, so we can initialize this thing. And next is the timer, like at which rate I want to send my data to this application. So here it is 10L. 10L here means the data has to be sent at a rate of 10 milliseconds. Okay. So this send sensor is the function which will be called periodically with this timer. And next, this virtual write, blink.virtual write, will write the data values to my application, which I will be showing just later on. So nothing here more is there. So we can like this section of the code here represents that we can also visualize the data on our console, like this Arduino console. And I will directly go to my Android app now. Just a second. Android app, Android phone, not Android phone. Teams. No, I don't have. From laptop. Minimize it. Sorry, stop sharing. Stop.
Share this in some laptop also. Just show them the details coming. Show them detail. Share from here also. Share from laptop also.
Okay, so shall I? So you just saw right now, like how the data we can visualize on our Android app. So, like, if there is a case that the data which we are sampling so like if there is a case that the sampling interval is the sampling frequency required is much higher than the one which we have been which we are doing till now. So in those cases it is not feasible at all to directly send
Share your laptop screen also.
it's visible now. It's okay now. So in those cases it's not feasible at all to send all of the data to an Android app or a cloud. So in those cases it is mandatory to like pre-process the data or take some decision at the device end so that it is feasible to not overload the application on which we want to visualize the data, right? So consider the case of an accelerometer which is highly used for monitoring the mechanical vibration of different objects. So the accelerometer data can be classified into three segments or along three axes. These are along x-axis, y-axis, and z-axis. So for the accelerometer to perform, we need the data corresponding to these three dimensions. Okay, so these pin numbers corresponds to the sensor pin number, sensor pin which has been attached to the microcontroller. So 15, 4, and 2 are the pins of the microcontroller. Next, I have included library which comes with the which can be used by the software to smooth the data streams, right? So by smoothing, we mean that we will be either like implementing a moving average kind of stuff, or doing an like or we will be smoothing using weighted moving average, exponentially weighted moving average. So here we can define these things, like the 10 here. The 10 here shows that we want to take average of these 10 samples, and for the for all these axes, for all the 3 axes, we have defined the same things. Next, for the loop, we can we calculated the final data, final input from the sensor, like as X final, Y final, and Z final, using the data sheet, using the conversion data sheet which has been provided by the sensor manufacturer. And lastly, we have added the values to corresponding to both the methods. So what I will do is that I will just show you a data stream corresponding to, let's say, Z axis, right? So I'm uploading my code here, and keep in mind that this delay 10 here represents that the sampling interval which I want to give. A delay of 1000 means 1 second delay or 1 second interval has been given. 10 means 10 milliseconds. So my code is getting uploaded, and from here I will be showing my serial plotter. Okay, so you can see that this data corresponds to z-axis vibration. Okay, so I have plotted one direction only. So the blue streams represents the noisy data streams, and you can see that red color is coming out. This red color is the moving average of 10 samples, and the green one is the exponentially weighted moving average of 10 samples respectively. Okay, so let's see how my 3 axis looks when I have smoothed out all the data points. So just okay, so here I've commented out every other stuff, and I just want to see the smooth value, smooth exponential moving average value of X, Y, and Z axis. So let us upload this code. Okay, so after I smoothed out, you can see that this data looks much more clear, and you can also see that if I give some kind of mechanical vibration to it, my data streams changes. Okay, so this can be a way to detect that any kind of mechanical influence has occurred. Okay, so how to capture this information using this device, so we can see in our next code. Yeah. So basically, this code contains exactly this code contains the pre-processing stuffs which I showed you in the second code. Now I want to classify it using k nearest neighbor methods. So my three inputs here basically belongs to the different basically belongs to the vibration along different axes. So we have three axes, so we have inputs three, and we want to classify that whether it is jerking or not jerking. So for each classes, we'll be training our model with 1000 data points. Okay, and for simplicity, let us assume that k is 6 here, but it can be tuned accordingly. Okay, so here I have normalized the data, and after that, each like there are two classes. So for each classes, we will be using thousands samples for training those classes, and after we have trained the model, we will the, this method will take a new sample and classify it whether it belongs to the jerking mode or it's not jerking mode. Okay, so let's upload this code. Yeah, so like I will be showing example of the sensor while it is being jerking. Yeah, so let's wait for 10 seconds and acquire the samples for non-jerking state. So now the model is been trained for no jerking state. So the training period has been done. Now the microcontroller will classify that whether it is in jerking state or not jerking state. So presently it is showing that it's not in jerking state, but whenever I am moving it or I am shaking it, shows some jerking state. So basically this is some kind of preliminary stuff we can do. Like with more advanced model, we can classify more like more classes or more vibration classes. So that's a thing for the other day. So thank you for now. Disclaimer.
Hello, is it audible? Is it audible? Hello, hello, is it audible? Hello, hello.
Yes, it is audible.
Yeah, thank you. So thank you, Shubhadeep and Shwatwit, for your presentation. So let me just share my screen. Yeah. So these are the technologies actually we have used in a real-time project. So I would like to showcase this project to you also. Okay. Hello. Hello. Is it audible now? Hello. Hello. Okay.
Audible.
So actually, these are the technologies we have so far used, and in a real-time project, we are using this kind of technologies. So I am just briefly explaining this to you. So this is a cold chain system. So we are trying to mimic a real-time cold chain system where some perishable items are being shipped from India to another country. So there are three stages. Mainly three stages are there. Like first one is model building for quality prediction. So we generally simulate some models, and we are trying to predict the quality of these perishable items. Here, in our case, we are using mangoes, and for better distribution planning, we are trying to implement this kind of models to our system. Second is traceability. So the traceability is actually for those mangoes from which farm it is coming, and what is the uh, to have a track record for these mangoes which are coming from the farmers to the end consumers. So for that, we are implementing a blockchain. For it is also very much popular for not being hacked. So this is also a secure system, but the main focus is on this monitoring system. So there are three stages here also. First one is we generally ship our perishable items through road transportation, and then maritime system using ships, and then for the distribution purpose, after it ends up to a port, then we ship it for distribution using road transportation. So in three of the cases, we used some of the sensors in different locations of this reefer container, and finally those data are sent to a remote database, and here we are processing and analyzing the data. For better understanding of this exporter, importer, and transporters, we are showing them the data in an understandable way. Okay. These are some pictures of our experimentation. Here is a container which is a real-time container, I mean, which is being used in real-life shipping. So we filled it. We have loaded this container with mangoes, and these are some of the pictures from our experimental setup. And inside this setup, we have used a camera setup, camera module. Two camera modules are there. So here, one camera module is for normal images, and another is for night vision images. So to know what is the quality of the mangoes, how much it has been shrinked, and what is the shelf life, and how much we have to distribute, what are the pellets are can be distributed right away. So these are the things we are for visually understanding. These are the things we were looking for. So, and these are the first prototype we have developed. This is the first sensor node, which you can see in the leftmost corner of the slide, and in the right, this is the master node, which is the IoT device, which is sending the data to internet as a gateway it is serving. There are several nodes and one master node. Here some processings are done. So this is already been done, and we are now working on prototype 2. And this is one web interface which has been developed by Satyajit itself. Our team has sent all the data to this database, and Satyajit is fetching data and showing it in this web page. So this was our project, and now we are open for some questions. I would like to take some questions if possible. Participants can ask some questions if they have any doubt. So I would ask again, we are open for any questions. If there is any doubt from audiences, if they can ask.
I should ask one question about the cold chain.
Yes, please.
The experiment setup that you have built, this was supposed to be in a real environment. So when you will be shipping the mangoes, it will go through a different set of temperature and pressure. I mean, a different set of ambience. So the experiment setup that you have built up, how are you taking care of those parameters?
Actually, when we ship those containers, so in from one port to another port, this is a refrigerated container, and the ambient temperature, humidity, everything is controlled. So throughout the journey, the temperature, humidity, and the ambient, the air quality, everything will be controlled. So I think when we set it to a particular parameter, then it will be same for the rest of the time. So I think that won't be a problem. So is there any other questions?
Good evening, Saurabh.
Good evening.
My question to you is, you have shown this device and Raspberry Pi thing. Is your prototype ready? Like, is it ready to bring it to the real supply chain?
Yes. First prototype is ready, so we can implement it to a real-time supply chain. But the thing is, we are working on prototype 2, where some of the algorithms we are planning to implement, and now we are working on prototype 2. So that's it.
Is it flexible enough to make a system and set up in the repo container?
Sorry, please come again.
Is the prototype flexible enough to put it in a repo container, or is it something very delicate and could not be placed in the repo container?
Yes, actually earlier it was a delicate prototype, but finally we got the sufficient amount of robustness. So I think it can be, it can handle any hazards in our cold chain. So I think that's it.
So one more question.
Yeah, please.
So you have shown us too many codes and some blogs as well. So how do you see this? Like, is the code available with you or at the community, at some community?
Yeah, please. So actually these codes will be available in GitHub repository. So we'll be sharing the links by mail.
Okay, sir. Thank you so much.
Thank you very much. So now, firstly, I would like to thank our head of the department, Professor J. Maithi, for giving us this opportunity. Then Professor Mamta Janamani, Industrial Systems Engineering Department, for guiding us throughout this session. I convey my gratitude to all the professors for their support and enthusiasm they have provided me all along. I would like to take an opportunity to thank our fellow team members Subodip, Satyajit and Ritik especially for helping in preparation of those PPTs and collecting those photos. And finally, I would like to thank all of you for your valuable patience and your attention. Thank you very much.